Assalamualaikum and hello everyone. So welcome back to the channel for the tutorial. So today the objective of this video is to show you guys how to do programming and what is the meaning of input output, how to set it up and how to use it. So we're going to start with the mikroC here. You can start your own project, new project. Okay, just go for the device that you want to use. Make sure the correct megahertz is being selected, and then there's nothing to be saved or add to the files. Okay, this should be a name. Okay, tutorial IO. So let's go for it. Project path. Okay, we are going to put here in the coding example tutorial IO. Okay, save. Then save the file. There's nothing to add in the project, so let's move on. So next, and then you are done. Okay, now you are going to have the default programming void main over there, because this is a C++ programming. What you can do is you want to start to write the program. Before we write the program, we just want to go back to the lecture slides. I will open up the slides for the first one on the pins assignment. Okay, hold on. Okay, I always show these pins, so I'm going to erase all of the things that shouldn't be there. Let's erase out this one. So we have 5 ports. Okay, remember that we have 5 ports here, and then all these ports you can use it as your digital IO. Okay, I'm going to write down first. So all of the pins over here, ports, port A, port B, port C, port D, and port E, which is shared with port A analog pins. So all of these ports can be used as digital input or output. So we are going to look one by one in the digital input and output. So I'm going to show you the easiest one is the output first. How to set those pins to output digital output. Okay, so I'm going to play with port B here again. Okay, let's try to play with the other ports. Port C. Let's look at the port C. So RC0, RC1, and then we have RC2, RC3, 4, RC4, 5, 6, 7 here. Okay, in Proteus, the assignment will be different. PIC 16F 877A. So we can go to get the component here. So the port C will be assigned over here. So this is port B, this is port D, and this is port A. So I'm going to play with port C. Okay, so let's look how we are going to set up this port as the output. Okay, in mikroC, so this is the main program, which is the void main. So you can write your program inside here. Okay, this inside here. I'm not going to use the while one first yet, because we are going to do it once. Because if there's no while loop, right? If you are not using any while loop, the program will read from the top to the bottom and ends. That's all. So let's try to do this one. Okay, the first one is to set up the pins that we want to use as output. So remember that if you want to set the pins as the output, you must use the trace register to set up. 0 for output, 1 for input. So thrice, and the port is C, thrice C is equivalent to 0B. This is binary numbers because we want to make it easier for us to look at the sorry, not just one, this one. Yeah, I'm going to open up this one. New file. Okay, for example here, port C, this is your pin. I just want to put like this, port C, 1 2 3 4 5 6 7 8. So this is possibly RC0 and this is RC1, RC7. So you have 8 pins. Okay, you have 8 pins. Then when you put 0B, this is to show how you want to set in terms of binary, which is 1 or 0 only. So 1, you are going to set it as your input, and 0, you're going to set it as your output. This is just to set the mode, because if you have this pin, it must know that it wants to be as what, it must be used as what. Now we are going to use these pins to be as the output, so it means that all will be output. And then this, the last one, is correspond to the RC0, this one RC1, and so on up to the last one. This is corresponding to this one. Okay, so right now in this process, I set up all these pins to work as the output. So that's the main thing. Means that if I set it up as the output, I can come up with this signal. I can generate a signal 5 volt from here, from the microcontroller to the outside of the pin, to the outside of the microcontroller. So it means that you can generate a pulse 5 volts from that, and you can generate go back to 0, and you can generate back to 5 volt, because it's always you can generate 5 volt. That means that it's going to be the top one, and then the second will be lower over here. All right, so this is the part that you need to understand. Okay, let's look at the programming wise. So I'm going to set up all of the pins as the output, 5 6 7 8. Then you have the semicolon. Okay, let's just do one very simple, because you already have the pins set up as the output. Now you're going to send a 5 volt signals for all the pins. So the command is port. You have to play with this port register, and this port must be at port C. This is a register. Okay, it's equivalent to 0B 00. Let's try. I'm going to use this one. 0000 1111. Okay, let's look at the results. So we are going to run this one first. Run this program. Where is it? Run project. How to compile this one? Build. Okay, build of projects. Okay, now you're going to build the project. Wait for the hex file to be generated. There's no problem here, right? So you can go to your Proteus. Okay, done. There's no red colors over there. Then you can start to set up your simulator. This is must be 20 megahertz. So where's the file? The file should be the tutorial just now under my OneDrive. SPMP, for example, tutorial studio, right? Is tutorial. This one, is it the one? Tutorial hex. Where is it? Let me check where I save as. Save as under tutorial video. Coding example tutorial video. tutorial video, this one. So this is the latest timestamp, 7:47 p.m. And then you can just go OK. And then from here means that the microcontroller already been flashed with the hex file. And then you can run this one. So you can see the output from here. The first 4 is 1111 according to this one, right? All this one is high state 5 volt and the other one is 000 volts. So the blue color means 0 volt and the higher one, the red color, is actually 5 volt. So we can try to measure it. I just want to confirm whether we can measure or not. So let's try to put a ground from here, which is a power ground. Is there any ground? Okay, it's okay here, ground. And then resistor. So we can find the component using this one, RES, resistor. Okay, RC1. This should be maybe just 1K, because if 10K, it's very high, so it means that your LED cannot turn on. So this one, and then you must have your LED. Okay, so LED, make it yellow. Okay, here you have your LED. Okay, now you can power up this one. Try this one and then this one. Then try again. You can see that your LED is turned on. Okay, let's try to do some measurement. I hope that we can do some measurement over here. This is a voltmeter, right? So this is a DC voltmeter. Let's try. Voltmeter must be ground to this one. Okay, let's run. It's 5 volt, is correct. So it means that the output rate here to the ground is 5 volt. Alright, the drop here is because possibly this one a bit inside there. We can try to measure the 0 volt here. Let's try to remove this one and then just go for the direct pin to the 0 volt there. There's 0, there's nothing coming out from the port C, because you set up as the output and you generate 0 volt. Okay, so that's one thing. So let's turn on this one. So this is very simple. We just run this one. This is very simple tutorial. You set up the port C as a using C register to make it as the output, and then you are going to give or generate the signal based on the pins. So this is the upper 4 pins and this is the lower 4 pins. These pins will generate 5 volts. Okay, so the command will be port C. Okay, if this program is run, it's only run once. It's not going to be a loop. So it means that right now you can start to use a loop. While 1, and then you must have the curly bracket. So inside there must be the body. Here another one. Okay, then you can see your program will keep on do this looping. Just want to show you how. So we can do a blinking LED. So right now you can put delay ms like 500 milliseconds, right? Then semicolon, and then you can turn on this one and then you can turn off this one. Alright, so we can just copy all these things and then we change this one 1111, and then we change this one, the last 4 is 0000. So this command will do the on and off. So make sure that you must put a delay before it go up again. So this is another delay, another one here. So the program will turn on this one, delay, turn off, delay, and go up back again, and keep on doing this until you stop the system. Okay, so let's run this one, compile this one first, build. Okay, it's done. So you can go to your Proteus and let's delete this wire and then try to have this voltage measured between the pins, and then we can run this one. Since that I'm using the same hex file, I'm not going to redo again to fill up the hex file. So now you can see the LED is blinking. It's 5 0 5 0 5 0. You can see the output coming from here is actually what you have programmed like this. So this is very simple output. You can turn on the buzzer, you can turn on this resistor, it's up to you. Okay, so that's the purpose of the output. So you must know that every time you want to use a pot, you must set up the pot mode, whether it's being used as the input or you're going to use it as the output. So right now, the objective for this particular programming is to look at the output. Now we're going to look how we want to use it as the input. Okay, let's go back to the this one again, so we can stop this one. Oh, it's already stopped. It's okay. So Proteus. Yes. Okay, so this is the one just now. Alright, so how we want to use as the input. So right now, for example, I just want to use one pin as the input. So we remove all this one first. I don't want you guys to get confused. So this is the two body, this is the wall body, this is another main body. So I'm going to use one pin from Tri-SP as the input. Okay, as the input, the rest is output. So let's generate all the signal from port C 0B as 1. So now by right, the output only can generate the signal because this is your input. It will not generate the signal, but as per the command, you have to write it up. Okay, so this one should be ignored because this is actually, you are waiting for the signal to come in. So for example, just now here, if you are setting up this one as the input, right, the input here is input. So right now, this pin is waiting to get the signal coming in, and then it can do some processing. So the signal must be also 5 volt coming in. That's why you need to use a switch 5 volt. Okay. Let's look at the command here. We compile this one again, and then look at the results. For this input pin, is it correct or not by using this Proteus? So double check the Proteus is still correct, and then we're going to run this one. Now you can see the first pin is gray. There's nothing coming out. This command is giving all 1111, which is a 5 volt voltage supply. You generate that 5 voltage, but this pin is not generated anything because even though you put as 1, this pin is working as the input. You must have the receive input, then it can work. So that's why you have to use a switch. So how to draw a switch? The switch must be used as a 5 volt and the ground. So you must have your 5 volt power supply here. This is 5 volt, right? And this is your ground. And of course, you must have a resistor used by this particular component mode. Res and use maybe 10K. This one should be okay for 10K. Alright, so this is a 10K here. It should be over here. Push you here, so we have to rotate it. Alright, like this, and the pin, we're going to make it move, and the pin will be like this, and then you have the switch here. Let's try to find a switch. So this is a part of switch. It's okay, we are going to use this one. I just want to, maybe I can use this one. Let's check. Push button. Push button, okay. This is much better. Alright. So I can use this one, the button over here, to the ground. So you have to imagine the rules for electronic, right, or electric. If you short this one, right, then the connection will be go to 0 volt. If there's no connection, it will go to 5 volt. So that's why you can measure the output, the signals here. I mean, if you have a multimeter, you can use multimeter here, DC voltmeter. Right now you want to measure which point? This point, right? This point to the ground. Okay, let's try to run this one. Right now it's 5 volt because this one is connected. When I push this button, it goes to 0. So that's correct. Right now, you are actually giving an input to the RC01. This is RC0. So based on this one, you're going to have this pin as the input. So right now, I'm going to give a signal to here. So right now what you can do in switch, you can do some if else statement. You want to check the switch, something like that. So let's try to look at the result. So I'm going to remove this voltmeter. Okay, remove this one. Check. Okay, now we want to turn on the LED. Okay, now we go back to this one, LED. Okay. Okay, this one. This one not much better, good enough. Okay. And then you must have the ground. Then you must have the resistor again. Okay, what I want to do right now is if I turn on this switch, then the LED will be turned on, just like your lightings like that. Okay, let's try to write down a program. Okay, so we are going to look at the input. If let's try to look at the input. The command will be, hold on, I just want to check the command. Okay, the command. If means that you are going to have the else statement. Okay, so means that if you have the command here, you must know how to use this one, else statement. So if must have the else. Okay, if must have the else. So if this statement, then you are going to do this bracket thing, and then if there's if the condition is not met, then you're going to use this one. Okay, so that is the first thing. Now you have to check which pins that you want to use. This is a pin 0, so you can check at pin 0. Okay, the command will be like this. If port C dot F0 is equivalent to 0 volt, then the output here, right? The output here, RC7, will be 0, nothing. Then you can generate the 5 volt signal. Port C, okay, is equivalent to 0B 00000000. So the pin that you are using is only C7, but it's okay. You can put the rest because the rest you are not connecting to anything. So now C7 is 0. So else, okay, else mean that you're going to turn on, right? You're going to turn on it. Okay, on this one you can put here. Port B, you're going to turn this one on, which is RC7. Okay, now you can compile this one. Let's try to compile this one. Okay, now there's a problem here in the command, so you have to put the semicolon here, and then you have to come semicolon here. Let's run this one. So it's successfully done. Okay, so go back to your Proteus just now. Okay, PIC 16F, it's 77A. Okay, and then you have the resistor, the power and ground. You have the power here, power, this one, right? Power. Then you have the ground. Then you have the resistor. Yes. And you have the LED. And then you can put it down. Resistor is this one. You can rotate. This is used at port C, pin 1, and then you have the push button. Push button here, this one, and this one. Okay, this is a switch input. Then you have the LED to go to the output, ground. Then you have this one. You can change this one to 1K, or maybe just 100. So you can see this is much brighter. So right now we are going to use this one. Let's put this one to 20 megahertz again, and then the file just now. This one just on 85, so this one should be correct. So let's try this one, run this one. Now this one is turn on, because by condition this is turn on if you cannot see anything at this port C F0 is equivalent to 0. So let's look at the result if I push this button. If I push this button, then you are going to receive this one as 0. Then the command will state that if I see this one as 0 volt, then I have to put port C all to low levels, means that I'm going to switch it off, else this one is going to be turned on for these particular pins. So you can see here how it works. So it should be a simple one for this one. Okay, so in this tutorial you have to do it by yourself, to play around to set up the ports as input and the output. Then you can start to use wall 1, you can start to use the command line, I mean the program on the measurement here, the power and supply. So that's all the things that you need to know. So here you are not going to put the crystal clock because the clock is already inside here. Remember that, even though it's a must to have the crystal clock, but it only put over here the setup for 20 megahertz. So the rest it should be okay. So this is how you can use this PIC to work as the input for this case, and the previous one just now you are going to use it as the output, which is you're going to trigger or generate the 5 volt signal going out. This is to generate a signal which is 5 volt from here, and then if you push this button, it will generate a 0 volt here to turn on, to turn out, to turn off this LED. So that's the first tutorial that you need to complete. So that's all for that one. Thank you very much.